Since I know you guys missed me so much, I'm back again with another lesson for flip geometry. Listen, I keep promising you the world premiere of Miss Robbins, but she is going to be coming really soon. You're going to hear her melodious voice teaching you some geometry. But we're going to go ahead and go into 4-2, which is angles of triangles. After this lesson, we will be able to apply the triangle sum theorem, which is something that you guys already know and love so very well. And then we're going to be looking at the exterior angle theorem. It's just two theorems that we're going to be looking at today. So let's go ahead and get on with the show. Listen, the triangle sum theorem is so ridiculously hard. I don't even know how to start explaining it to you, but it should have been something that honestly you've seen before in middle school. You've got three angles in a triangle. The three angles, the sum of all three of them, is 180 degrees. We have here measure of angle A, B, and C. The three angles, the sum, no matter what size, the shape, no matter what it looks like, the sum of all the angles will be 180 degrees. I've just been challenged by Miss Shivers to talk like this throughout the entire video. Okay, so I'm gonna teach you guys how to find the measure of angle 3 in this video. Okay, here's angle 3 right over here. Okay, but we got to work with these two way over yonder. Okay, if we look at this triangle first, okay, I'm gonna go ahead and trace it. This angle's 38, this angle's 67. We need to find that one. So how do we do that? We can set up a little quick equation. 38 plus 67 plus, we don't know what that one is. We're gonna call this one x equals 180 degrees. Combine our like terms, 38 and 67 is 105 plus x equals 185 or 180, sorry. Subtract 105 from both sides and x equals 75. That means angle 1 is 75 degrees. Okay, now that we've gotten taken care of angle 1, we'll go ahead and erase all this extra stuff that we don't need right now. Okay, now we go on to angle 2. Angle 1 and angle 2 are vertical angles, and if you remember from our previous chapter, vertical angles are congruent to each other. So the measure of angle 2 is also going to be 75. Okay, now we know these two angles, 75 and 48. We can add these two together, write ourselves another little nifty equation over here. Okay, 75 plus 48 plus x, we don't know what the third one is, equals 180 degrees. 75 plus 48 is going to be 123 plus x equals 180. Okay, subtract 123 from both sides, and x equals 57. That means the measure of angle 3, boys and girls, is going to be 57 degrees. Thank you. Have yourself a great day. Make sure you go by and tell Miss Shivers that I can do this all day and all night if you ask me to, okay? All right, moving on. All right, we're going to talk about the exterior angle theorem, but before that we need to go into some vocabulary. So I'm looking at this figure here. We've got a triangle ABC. If we were to extend one of the sides of the triangle, as we've done here, it creates an angle here, angle 1, which is on the outside of the triangle. That's what we're going to call our exterior angle. Okay, exterior angle. That's our exterior angle right there. Okay, now these two angles that I'm going to highlight now, these two on the inside, we're going to call those interior angles, but the specific name is remote interior angles. Those two angles are going to be the remote interior angles. So like I said, the two words that you want to look at are exterior angle, which is the one that's on the outside of the triangle, and then the one next to it on the inside is adjacent. Remember that word adjacent, which means next to? We don't need to worry about that one right now. This one here, these two are the remote interior angles. They're the ones that are away from our exterior angle here. Okay? So, the exterior angle theorem says that when you add the two remote interior angles, if you add those two together, the sum, okay, remember, look, the sum, it's going to equal the measure of the exterior angle. So when you add these two on the inside here together, of the measures of the remote interior angles, you're going to get the sum of the exterior angle. It's going to equal the exterior angle. Let's take a look at a few problems there. This question is asking us to find the measure of angle FLW. If I highlight FLW, this is the angle that we're looking at. Okay? So, but we need to set up an equation to figure out what this is. If we were to do that, let's take a look first. We've got two interior remote angles, X and 32, and then we've got this exterior angle here. And the exterior angle theorem tells us that the sum of the two remote interior angles, so I'm going to go ahead and write that. The sum of those two is going to be X plus 32 is going to equal our exterior angle, which is 2X minus 48. So let's go ahead and solve for X here. Go ahead and do this very quickly. This leaves us with, now I've got the calendar, and today is the 12th. So I'm doing this on Wednesday the 12th, of course. X minus 48 plus 48 on both sides. X equals 80. But we don't need X. We need the value for the measure of FLW. So if we plug that value back into our equation, so 2 times 80 minus 48, that leaves us 160. Well, I'm not sure what I was doing there. So let's erase that. 160 minus 48, and our answer is going to be 112 degrees. Just want to talk about very briefly about some some things I want you to know about triangles. First thing is, the acute angles of a right triangle are complementary. Well, this should be common sense, just because if we look at a right triangle, we've got that right angle down here. The other two angles, if that one's 90, this angle here and this angle, the sum of those has to equal 90, because 180 minus 90 is 90. And if we have two angles whose sum is 90 degrees, we remember from, I believe, chapter 1 it was, that those two angles are going to be complementary. Now, when you have a triangle, it can at most have one right or one obtuse angle in that triangle. You can't have a triangle with more than one obtuse or right angle, and it cannot have an obtuse angle and a right angle in the as one of its measures. So just remember that can be at most, sorry, I'm fumbling my words, there can be at most one right or obtuse angle in a triangle. Alright, boys and girls, I'm about to tell you a secret that no other geometry teacher wants me to tell you. Okay? So just keep this to yourself. Don't tell any of your friends, any of your classmates, any of your enemies. But you will see one of these type of problems once again on your quiz or on your test in the very near future. I love these problems, and you will learn to love them too. So let's get to it. We need to find the measure of each numbered angle. We've got angle 1, 2, 3, 4, and 5. We need to figure out what each of those measures are. Okay, we're going to start with number 1. Since we have 45 and 85 there, we can add those together, and that equals 130 degrees. So if that's 130, this one, if we subtract that from 180, 180 minus 130 is going to leave you with 50 degrees. Since angle 1 and angle 2 are vertical angles, and vertical angles are congruent, then the measure for angle 2 is also going to be 50 degrees. Okay, now we get to angle 3. There are a couple of different ways to figure out angle 3. I'm going to do both of them for you. Now, first we want to notice that we have an exterior angle out here, 135. Remember? If you remember that angle 2 and angle 3 are going to be the remote interior angles, so 50 plus whatever this is going to be 135. So all we have to do is subtract 50 from 135, and that will give us an angle measure of 85 degrees. Okay? But another way you could have figured that one out, let's go ahead and erase it and start over. Another way you could have figured that one out is if you look, these two angles here create a linear pair. And if this is 135, then the angle next to it has to be 45 degrees. And if you add these two and subtract from 180, then you've got 85 degrees. It's the same thing. Either way, angle 3 is going to be 85 degrees. Okay, now angle 4, if that's a vertical angle to this angle here, those are going to be congruent. So angle 4 is going to be 45 degrees. Last but not least, we've got angle 5. That's the exterior angle to these two remote interior angles. And if you add 45 to 75, you get what, Miss Robbins? She's sitting right next to me. She can't do this math in her head, but I can. Yes, she's absolutely correct. The answer is 120 degrees. Okay, kids, in the last slide I said Miss Robbins, who's a geometry teacher, can't do math in her head. Well, she got in her feelings and she started crying a little bit. So I just want to apologize to all of her students who may be watching this video that she can do math in her head, just not anything over 5 plus 5. Anyway, 4-2, we are done with the angles of triangles. Go ahead and do some of those problems. Actually, don't do some. Do all the problems in the homework. And come back to me if you have any questions, okay? Only me. And remember, be happy. Don't worry. Be happy.